Okay. Okay. So on one side, what do we have? Sales minus variable cost minus fixed cost equals profit. So our selling price was $88. Our variable cost for the mountain was $52.80. Our total fixed cost for the mountain skis, $369,600. And you make that equal to, well, what was my other option? My other option was to sell the touring skis at $80, spend $52.80 in variable costs, and $316,000 in fixed costs. And so I want to find out at what unit of sales would it make no difference to me which I sold, whether I made mountain or whether I made touring. I would be indifferent to the decision. So when you subtract out selling price minus variable cost, there's your contribution margin. You could start here because selling minus variable equals contribution margin times X minus fixed cost. And this is the contribution margin for the touring that we had minus its fixed costs. So when you solve for X, we find out our indifferent point is 6,600 pairs of skis. So that at the lower amounts, we're going to want to sell touring because they have less fixed costs to cover. At higher amounts, we're going to want to sell mountain because they give us more per unit once we've covered our fixed costs. So the 6,600 point is where the difference is. At below 6,600, we'll go with touring. And above 6,600, we'll go with mountain. And if you're not sure, Part E says, well, what if you sell 12,000 pairs? Which one are you going to pick and why? So what did you do? You take your formula here and stick in 12,000. Take your formula here and stick in 12,000. Your profits, if you sell them 12,000 pairs of mountain bikes, would you rather make 52,000 or 9,000? You're not indifferent anymore. You're above the indifference point, and above the 6,600, you go with the mountain bikes, the mountain skis. And this is proof. This is doing, what is this? This is selling minus variable minus fixed. So the contribution margin minus fixed cost gives you, that's your net operating income. Actually, it should be NOI, net operating income. Okay. And so that's what you ask yourself. Under which option will I be better if this is what I think my sales are going to be? I definitely want to go with setting up my factory to produce the mountain skis. Yeah.
Just to clarify, in Part A, the break-even, the indifference point of profit, that's a negative profit?
Oh, yes. Okay. At
80?
6,600 pairs. Thank you. If you stick 6,600 in this formula, you're at both of them, you're going to have a loss of 137,280. Okay? You don't want to be there. All right? What did we say our break-even point was in the beginning? 10,000, where was that? I gotta find my numbers again. Okay. We said that for touring, the X to break even for touring was what? 13,118 pairs. So if we're only selling 6,600, we're not breaking even. We're going to have a loss. What did I do the mountain ones? If you do the, let's see. I did, okay. If you work out the break even for the mountain, so that's 369,600 divided by your contribution margin of 3,520, you only need to sell 10,500 units. Is that right? 1,300? Oh no, that is not break even. That was with the 40,000. I take that. That is. Can somebody do 316,800 divided by 2720? That's what I need. That's what's not making sense.
116,470.
No. That's
316.
Say it again. 316,800 divided by 27.2.
Oh, 27.2.
Yeah,
11,647.
11,647.
I got it. Okay. Okay, so this is what we need to sell to break even under either scenario. Well, at 6,600, we're not breaking even. What this is saying is at 6,600, we are at the same profit or loss situation. We don't want to be there. All right, so at this point, even though we can calculate the indifference point, it's telling us that this isn't going to help us make our decision, because at less than 6,600, we're going to want to go with touring, but we don't want to be there because we're going to be in a loss situation anywhere. So that's a decision that isn't making sense to make, because in both cases you're at a loss. What it says is at less than 6,600 pairs, you'll have less of a loss if you sell touring. At more than 6,600 pairs, you'll have less of a loss if you sell the mountain bikes as you move up. And why is that? You're going to break even here at 10,000 units. You're going to break even there at 11,000. Good.
I guess I'm trying to figure out where I would use this in the real world. Does it, because with these negatives, like, why would I calculate
With
this?
Well, because you don't know it's going. You don't know it's going to come out to 6,600 till you do it.
So for a certain percentage of time, you'll actually wind up with a positive.
Like the one we did,
Okay.
like the one we did earlier. Yes.
Okay.
Yeah. Most of the time, you're trying to decide between two valid options.
Okay.
So they should have positive. They should have an indifference point that gives you a positive net operating income. All right. When it gives you a negative net operating income, it means you really shouldn't be thinking about one of these products. And if you look here, this is telling you at 12,000 pairs how little profit you're making on this one compared to this one. This is telling you that, pretty much at anything above 6,600 pairs, you want to go with the mountain ones. You'll have less of a loss and you'll reach a profit sooner than if you went with the touring. But you're right, when you get the two negatives, what it's actually telling you is that one of these really should get thrown out. Okay? But most of the time you get two positives and you're trying to figure out, okay, where are my marketers saying I'm falling on the graph? Where do I think I'm going to sell? So it just gives you more information about which product I should pick. In this case, when you have the negatives, right away you want to figure out, okay, let me look at my break-evens. I'm going to break even sooner here, and I'm going to make more profit at my projected sales. So that you're just not even going to consider the touring. But you will get negatives sometimes, and this is an example. And I said, what that does tell you is one of these should get thrown out. Okay? And Part E shows you why it should get thrown out. Why would you want to go through the trouble of selling of 12,000 pairs of skis and make that little profit when you can make that much, that much more? Okay. So the indifference point is just another tool to help you make a decision if you've got two options and you're trying to see, again, which one is going to best fit your market expectations. All right. It's no good. You can, like we did in the other problem, we calculated two positive NOIs. At the indifference point, the net operating income is positive, but unless you have valid data from marketing, you're not gonna make a good decision. Unless you have valid data on how much you think you can sell in this market, you need that to use the indifference point the correct way. Okay.
I have a question.
Yeah.
So the net operating income, right, Part A, is the, it's a contribution margin, it's sales, the 12,000 pairs?
Yep. It's $88 in selling price minus variable cost to give you contribution margin.
Okay.
And again, you could have done it the long way. You could have done the whole thing here and stuck in 12,000 and stuck in 12,000 there. You wouldn't be at an indifference point anymore. You would have this side equaling 52.8 and that side equaling 9,600. See, okay? I'm going to get rid of the indifference point now. All I did in Part E was, instead of an indifference point, I stuck 12,000 in here. Well, 88 minus 5280 is 3520. Okay? Same thing there. And then if you solve this, you get 52,800. If you do this side of the formula and stick in the 12,000, okay, you're only going to make 9,600. Selling price minus variable cost minus fixed cost gives you what? Net operating income. Okay. Anybody? What I really need you to do is think about it for a week. So now, since we did the two of them tonight, think about the indifference point and how you can use it and what it's telling you. The best way to do it is, once you get your indifference point, if you're not sure which way to go, stick a number in. Stick a number above 6,600 and below 6,600 and see which one gives you the better bottom line, and that's how you know which direction you go with your indifference point. Whether, like I said, if it's lower than 6,600 units, you're going to have a less loss if you stay with touring. But above 6,600 units, you're better off going with the mountain bike, the mountain tour, mountain skis, mountain biking on the brain. Okay. You're not going to have to do an indifference point for the project. Okay, you don't have it updated. Let's put chapter 3 to bed for a while. Let's look at chapter 4. There is something in chapter 4 for everybody to love and everybody to hate. What it is, it's a series of decisions that you can make looking at what the relevant costs are. So there are all sorts of decisions, and okay, how do we decide if we're going to shut down a division or not? How do we decide if we are making computers, if we make the chip or do we buy it from Intel? How do we decide if we have excess capacity to accept a special order? How do we decide if we can sell a product the way it comes out of the factory? Do we sell it that way, or do we process it further and sell it for more money? They're all very different decisions. They all use the exact same analysis, which is looking at your relevant costs. Are they variable or fixed? And what's the bottom line? So we're going to look at, I think, 5 categories of decisions that there's a lot of variations under them, but they usually fall into the same types of categories. Okay. I'm going to list them out, and then my problem is I've got my sheets all over again. Okay. And Post-it notes and all right. Okay. So. And what we're going to do is one exercise for each. So the first one is to add or drop, and this could be anything. Add or drop a segment, add or drop a division, add or drop a new machine. All right, so do we stay with what we have, or do we replace it? Do we get rid of it? So that we're going to be making a decision about, do we stay with what we have, or do we change it, drop, add something to it? So in that one, we're going to do 416. Okay, the second one is make or buy. That was what I just said. If we're making this computer, we could buy the chip from Intel, or should we be making that chip in our own factory? How do we decide which is better for us to do? That one is 423. The third one is what I had said before about special orders. If we have excess capacity, how do we decide whether or not we should take a special order or reject it? Or how do we price out a special order? Somebody says, well, can you make me 1,000 of these? What's it going to cost me? Well, you've got to come up with a cost that covers your additional incremental costs and hopefully still gives you a profit. Okay. Using scarce resources. Okay. Your factory has limited capacity, or your people have limited capacity to provide different services. How do you decide which products you make with those limited resources? Or how do you decide if you've got so many staff hours, what do they get relegated to? What do they work on? Let's say you've got work that could take 10,000 staff hours, you only have 8,000. That's all you've got. How do you decide which jobs you're going to take, which jobs you're not? Or in production, how do you decide what you're going to produce right now if it's a temporary scarce resource and what you're going to hold off on? It could be a scarce material. It could be like rare earths that we're having problems with. It could be a scarce resource like labor. You only have so many people on the line. It could be machine hours. Even if you're running 3 shifts, your machine hours can only run the 24 hours a day. And suppose you've got 26 hours a day's worth of orders. How do you decide what you're going to produce? So that's the decision about scarce resources. And these are all short exercises that are going to demo them. And then the last one is what is called joint processing. Doesn't really, it's basically, do we sell it split off? So when we process to a certain point, all right, so we start out at point 0, and we get a product that's 100% done that we could sell to the market. However, we could add, let's say we're making chemicals. We can sell this chemical that comes out on the market the way it is. We could add some additional costs to it and come up with a totally different product and sell it for a lot more. How do we decide? Do we sell it at split off, or do we process it further and sell it for a higher price? Or do we do a combination? And so that's what's called joint processing. Up until a point, these costs here are irrelevant. Your choice once you're here is, do you sell here or do you process further? And so that's what this last decision is. You see it in a lot in chemical processing. You see it a lot in food processing. Okay. For those of you who are vegetarians, I'm probably going to gross you out during this piece, because if you think about what they do with meat, when they butcher a cow, they can sell a half a cow to a butcher and let the butcher break it down into steaks and whatever, or the meat processing place can take that cow and process it itself and sell it as steaks, hamburgers, and whatever. How does it decide whether to sell it unprocessed to a distributor or break it down and sell it as finished product? Okay, so you see it in chemicals, and you see it in a lot of different food processing decisions. The problem is that how do you decide what costs are relevant? What costs are important here? Well, if the costs between decision A and decision B don't change, then those costs are irrelevant. You could put them in your decision, but they're not going to make any difference on your bottom line. What you're trying to isolate is what are the differences in costs and revenues between your two options. If a cost is the same between the two options, you don't consider it because you've got to pay it either way. It's not relevant to the decision. What you have to remember, where do you go here? Okay. Sunk costs are costs that you have paid in the past. They are historical. They are always irrelevant. I bought my Toyota Sienna in 2004 for $32,000. So what? What's relevant? What I could get for it today, which wouldn't be too much. The historical cost is irrelevant. I can't get back $32,000. It's never going to enter into the decision. The decision is what can I get for the car today? So what you paid for something in the past almost never enters into the decision. What's relevant is what is its value in the market today? What's its salvage value? My car that sell for pieces. Okay. So those sunk costs usually do not enter into the decision. Future costs that don't differ. So if you have future costs that are equal, so that both options are going to cost you the same amount in direct labor in the future, they're irrelevant. Okay? What you have to do is eliminate all the costs that are not different or are not connected with the decision. And then you make your two columns. Decision A, decision B. Which one gives me the better bottom line? Which one gives me the least cost or the most revenues, depending upon how you're trying to answer it. The last are opportunity costs. They are the net benefits that you're giving up by choosing A over B. Okay. By choosing to come to class tonight, the cost to you was having a nice dinner with your family or staying home and watching TV. There was an opportunity cost to that. They usually don't enter into the direct decision. They usually come once you get your bottom line, that's your starting point, then you start looking at what did I give up for this to help make your final decision. You look at your qualitative factors. Well, if I shut down this factory, 1,000 people are going to be out of work in this town. And as I said, some companies will say, who cares? My bottom line is to my shareholders. Other companies might reconsider. Okay. So that there's a lot of qualitative stuff. All we're going to do here is get to that first point for each of these decisions, which is get a number to compare. And then next week we're going to talk about what are the soft factors that go into making the decision. All right. So if you look at the the first one, 416, is new or old machinery. Okay. So what we're trying to decide is in exercise 16, we bought x-ray equipment. We're on page 117. Had a useful life of 10 years, annual operating cost of $40,000. However, technological advances have made our machine obsolete. Just trying to find my worksheets here. Where's that? Okay. Hang on, I can't find my notes to put the numbers. And so what we're trying to figure out is how do you decide I'm sorry here, my papers got totally messed up when I was How do you decide whether or not it's worth it to buy the new machine? Because even that machine is only going to last 6 years. That's the problem when you've got high-tech machinery. As soon as you buy it, it's obsolete. So that when you're buying machines that supposedly have 10-year lives and only last for 4 years, that's where your sunk cost comes in. And it's very hard for people to say, but I've paid so much for that machine. Well, it's not worth that anymore. It's worth whatever the salvage value is that the market says it'll pay for it. So that trying to disregard sunk cost is one of the hardest things in these decisions. So when we're looking at 16, where we want to compare, we're going to look at replacing versus keeping. That's all we're trying to decide. Do we keep our old machine or do we replace it? So what you have to do is compare across the two machines, what are the differential costs? Okay. So when we're first thing we're looking at, okay, the life issue right now, our machine is now obsolete, has 0 salvage value. So it's worth nothing in the market. We can't sell it for anything. We're going to hope somebody will just haul it away. We have a new improved machine that is available at an initial cost of $55,000. So if we replace, we're going to have a cost of $55,000, right, to buy the new machine. It has annual operating costs of $26,000. Okay, so our operating costs are $26,000 a year, and we are going to be able to keep that machine for 6 years before it's obsolete. Okay, so that our total operating costs over the life of the machine are $156,000. So if we replace our machine, we've got to buy the new one, and then when the cost associated with running it, it's going to cost us $211,000 over its 6-year life. Well, now, what's going to be the cost to us if we keep our old machine? Well, if we keep our old machine, you're told that annual costs of $40,000. So we have annual operating costs of $40,000 a year. And if we keep those for the same 6 years, so if we keep the old machine, we're going to spend $29,000 more. There's a difference of $29,000. So as much as we would hate to throw this machine out, it's actually going to be cheaper for us in the long run to throw this 4-year-old machine out and buy the new one. Because the new one is more efficient by $14,000 a year. And that savings over the 6 years pays for the cost and comes in it. So overall, you come in at $29,000 compared to what we're doing now. The hard part is you're thinking, but I still have 6 years left on this machine, 6 years worth of useful life. Yeah, but it's going to cost you $29,000 more to do that. At some point, you have to say, okay, we've got to just throw it away and go with the new machine. The mistake that was made in the analysis here was saying, well, wait, we still have $30,000 left on this machine in useful life. No, you don't. The market value of your machine is 0. If you could sell it for $30,000, the salvage value, then the $30,000 would be relevant. You have to write that $30,000 off. You paid for it. You paid for this machine already. It's a sunk cost. You can't get it back. Market's not going to give you anything, so it's irrelevant to the decision. And so that's what happens. If you had put that $30,000 in here, this would have come out to be the better decision by $1,000, and you would have made the wrong decision. You'd cost your company $1,000 rather than saving it $29,000. So the hard thing here is to plow through all these numbers and say, this is irrelevant, this is irrelevant, this is what I need to look at. Okay. So questions. So whether you're looking at adding or dropping a division, you're going to do the same thing. What am I doing if I keep the status quo? I'm going to have revenues and expenses from the division. What's going to disappear if I get rid of the division? All the revenues and all the variable costs. But the fixed costs are going to stay. So you have to see, am I better off with the division or without the division and carrying its fixed costs? So use the same type of analysis. Okay. Questions? So they're all going to be variations on a decision. And you can't make these decisions unless you know, well, does the cost go away? Is it variable or does it stay? Is it fixed? Is it a sunk cost that I can't get back? Or is there a salvage value in the market? Okay, so the make or buy decision is where, again, you've got companies that decide, do they want to make some of their own components or do they want to buy them externally? And the problem, you can do that two different ways. You can list down all of the costs associated with making it versus all with buying it, or do it incrementally. Actually, all of these can be done that way. You could do an income statement before and after for total costs, or you can just do the incremental cost. You will get the same bottom line difference. It's easy, well, not easier. Some people think it's easier to do the incremental. Others think it's easier just to do two income statements. I don't care what you do. You'll get to the same decision. You'll make the right decision. So if we look at making or buying, we're trying to decide, do we want to outsource? Okay, we make a line of air purifiers, so on page 119. Okay, we're currently evaluating possible production of an air purifier. And on a base of 10,000 units, we've got costs here. So we've got so on a 10,000 unit volume, our direct materials are $8, our direct labor is $1.50, and our overhead is $7. And right away, we know that has to be broken down into variable and fixed. Okay. Materials is variable, labor is variable, overhead is a combination of variable and fixed. So we know, you know with these, you have to do that if it's not given to you. Okay. These cost predictions include $50,000 in facility level fixed factory overhead. So that there's $50,000 in factory costs that are not specific to this production. They are spread over all production. Okay, they are not unit specific. Okay, so that what we've got in this overhead is part of that facility level fixed factory overhead, averaged over 10,000 units. So what that tells us is if our fixed overhead is 50,000 and they're spreading it over these 10,000 units, our fixed overhead is $5 a unit. Well, if our overhead is 7, that means our variable overhead is $2 per unit. Okay? So what we now have is all of our costs broken into variable and fixed. One of the component parts is a battery-operated electric motor. We currently don't make them, but we could. We have excess capacity. there's an external company, Mini Motor Company, is offering to supply us with the motor. Okay. If we order 5,000 units, well, we're currently doing 10,000, okay, so we're fine there. If we accept the offer, we're going to be able to not make the motor and instead buy it outside. So it'll reduce variable labor and overhead costs by 50%. What do? Do we make it in-house or do we outsource it? I mean, that's a question a lot of companies have to answer at this point. Okay. So what we are looking at is a make versus buy. Do we make it internally or outsource it? So what we need to look at is what are the costs associated with buying, okay? If we're making 10,000 units, we have to buy 10,000 externally. And they're going to sell them to us for $5 a unit. So our cost to buy is $50,000. Okay, that's pretty simple. That's what the outsourcing, that's what they're going to sell them to us. If we make it internally, okay, we're told that, okay, we'll be able to reduce the electric motor's components cost $2 if we make the motor. Okay, so that means that $6 is for the rest of the air purifier and $2 is for the motor. Okay. It also says that we would be able to reduce variable labor and variable overhead by 50%. Well, that means that 50% of the labor and 50% of the variable overhead belong to the motor. If we don't make the motor and those costs disappear, they have to be the cost associated with making the motor. So that 50% of direct labor goes to the motor and 50% of the variable overhead goes to the motor. So what you're trying to do is back out of these costs. If we get rid of the motor, what's going to disappear? What are the costs associated with making the motor? Okay, so this was to purchase. We had 0. But if we are going to manufacture, we are going to have direct material of $2 times 10,000 units. We're going to have direct labor of 50% of $1.50 times 10,000 units. We're going to have variable overhead of 50% of $2 times 10,000 units. We stop there. So what you had to do was literally take each phrase and figure out, okay, what are they trying to tell me? So out of this $16.50 cost per unit, $2 of materials for the motor, 75 cents was labor for the motor, $1 of variable overhead was connected with the motor, and if we don't make the motor, if we make the motor, that's what it's going to cost us. What is it going to cost us in fixed cost if we make the motor? Or if we don't make the motor? Will fixed costs change here? What are my fixed costs if I buy the product? They're fixed. 50,000. What are my fixed costs if I make the product? 50,000. They're irrelevant. If you put them in here, you could put 50 here and 50 here. The difference in your bottom line is still going to be the same. But they don't differ between alternatives. So if you're doing incremental analysis, you can leave it out. If you put them in, I would take it as long as you've got them both in both columns, because the fixed costs don't change. They're overall factory costs. They do not disappear if we stop making the motor. So they're not relevant. So the relevant costs are 20,000, 7,500, 10,000. Okay. So our costs to make are 37,500. Our costs to buy are 50,000. So if we outsource, we're going to lose $12,500. Everybody see why? Okay. If we continue to make the motor in-house, this is what we're going to spend for material, this is what we're going to spend for labor, this is what we're going to spend for variable overhead. Okay. If we buy it externally, we're just going to spend the 50,000. This is irrelevant to the decision because it's fixed. It's there. And if you had added 50 to both sides, the difference is still 12,500 in favor of making internally. Okay. Now, with a make or buy, there is always the possibility of alternative use for your space. If we don't make these anymore, well then we've freed space in our factory. Is there an alternative use for our factory? Can we rent can we rent a portion of our factory out to somebody? Okay. But the first thing you look at is, okay, just looking at if we stop making and we buy externally, we are definitely better off by a lot by continuing to make the motor in-house. Okay, and that was part A. Now part B says, well, if we freed up this space by not making the motor anymore, and we can rent that space, or we can use it to make another product, then what does it do to the decision? All right. Well, if we can end up, let me just put this here. All right. What'll happen is if we can buy for the 50,000, but we can reduce that cost by the rent of the extra space, well then look what happens. It's only going to cost us 30,000 if we outsource, 37,500 if we stay in-house. So if you have an alternative use for your space, that's going to change your decision. But if your choice is we stop making the motor and we can't do anything with the extra space, then you continue to make the motor. However, if we have a use for that alternative space, it reduces our costs by the net of the rent, this one becomes the better choice. So with make or buys, you always do an initial and then consider, okay, with the freedom of space, can we use it to make a different product? Can we, whatever. Question. So see, we're looking at the same kind of costs, but you're asking different questions each time. The third one is a special order. With special orders, the rule of thumb is if you don't have excess capacity, you're not going to be considering a special order. Because if you don't have excess capacity and somebody comes to you with a special order, what does that mean? It means you've got to short one of your regular customers. So why would you make one of your regular customers unhappy in order to take a one-time special order? Okay. So what you need to figure out is first, do I have the excess capacity? And if you do, what can I cost it at so that it makes it worthwhile for me to take the special order? Okay, so that's number 17. So on page 117, okay, we make wall mounts for, let me just stop here for a second. Okay. What we're going to look at next week are, once you get the numbers, okay, there's obviously going to be issues here. If we go with buying instead of making, we'll save $7,500. But what are some of the issues we're going to have to worry about if we outsource?
Shipping costs, assembly costs.
Well, hopefully that's built into here. That 50,000 is the cost to get us that. Right? If they're not been considered, then they need to be considered. But what are some issues if you outsource? If you outsource anything? Quality control issues. If you're making it in-house, you've got total control over quality. What about what they're making? Is it going to be the quality that you need it to be? And if you stop making it and you outsource and then you have to ramp up again, it's going to cost you a bit. So you'll have to worry about quality. Okay, what else, again?
About consumer backlash. They might not support you if you outsource.
Okay, that, you know, before if you're making the whole unit and now you're buying pieces from other, other manufacturers. Again, consumers, rightly or wrongly, may have a different view of your product. What about the outsourcing company?
Stability of the price they're charging you.
Okay. Is this $5 going to skyrocket after 2 months, after a year? Okay, they're saying they can supply us to 10,000. Is that temporary? Are they just trying to use their extra space? And then in 3 months they're going to say, sorry, we can't supply you anymore? But none of that comes in here. This is just the starting point of your decision. Then you have to start looking at what are all the qualitatives. I'm just trying today to go through the quantitative pieces. And then next week we're going to spend time doing the Chapter 4 problems, looking at, okay, what are some of the things that aren't in these numbers that may make you stay in-house, even though it might be slightly cheaper to go and outsource. So for the special order, what we've got is we make mounts for panel TV sets. There's your forecasted income statement, $44 a unit, and so on and so forth. Of the production and selling costs, certain ones are fixed. Okay, so what they're doing right now is they're breaking down your product and period costs into variable and fixed. You need to know that because fixed costs are not going to change with your decision, but variable costs will. Okay, so sales, cost of goods sold, selling, general and admin, and then net operating income. All right. So of the production costs and the selling costs, 800,000 and 100,000 are fixed. Well, what that means is the other are variable. Okay. All right, so that from that just that one piece of information, we now have broken down all of our costs into variable and fixed. We have a special order from a hospital supply company. They want to buy 12,500 units. And they will pay $30 for them. We're currently selling them at $44 in the market. That may or may not be relevant. We have sufficient excess capacity. All right, so we're going to look at it. Why wouldn't we? Okay. The company's sales manager argues saying, well, wait a minute. Our cost of goods sold is $32 a unit. Okay. we're paying $32 to make it and we're gonna sell it for 30. Well, if you look at the cost of goods sold as totally variable, so that if it disappears, the total 32 disappears, but it doesn't. Some of this $32 is a fixed cost. So whether we take the order or not, it's not going to cost us $32 to make one of these units. What's it going to cost us? Only the extra variable costs that we incur. The fixed costs are going to stay. So this 32 is not the cost per unit to make it to make the additional units. We want to know what are the incremental costs to make these 12,500 units. Well, we're going to have increased variable costs. And what are they? You're told that, okay, from the information given, let's see. Should we sell it for 30? So what we need to figure out is, if we are given a proposed selling price of 30, what are our variable costs? What are the variable costs associated with making one of these units? We're going to get $30 for it. What's the cost associated with making it? Well, first of all, you need to figure out what's the variable cost per unit. See, this is where some of you are going to get stuck. You've got to back into the numbers. How many units did we make? If you don't know that, you can't do the problem. So what you want to do, if we need information by unit, that means somewhere here you can calculate how many units we made. How many units did we sell? 44.4 million, and we sold them for $44 a unit. Divide that out, it means we sold 100,000, we made and sold 100,000 units, okay? If we got 4.4 million in revenues, and we sold each unit for $44, sales divided by the sales price per unit is 100,000 units. So what is our variable cost? Our variable cost per unit is over 100,000. Our variable selling, general, and administrative is divide by 100,000. So we can come up with a variable cost per unit for cost for production. We can come up with a variable cost per unit for SG&A. If we make another unit, it's going to cost us $24 in variable costs. For every additional unit we make, it's going to cost us, is that right? $2, right? My number's not right. 24. 1. Okay. 24.32. I don't like my numbers. Hold on for a second. 44. 2, 8. 24. Okay. I'm obviously in the math error. Okay. So our variable costs are variable costs for production and variable costs for selling, general, administrative. Okay. So now what we need to figure out is what costs are going to be associated with the, oh, I know what it is, okay. What costs are going to be associated with making the product for them? We're going to incur material, labor, and variable overhead. Okay. Are we going to incur any additional SG&A? This is a special order. Odds are, and you're not told anything about there being a commission. So when you're looking at variable SG&A, the variable part is usually commission. On a special order, there usually is not a commission. Okay, when you look at the problems will be very clear about that. This one is not clear. Okay, I would have taken here either 24 and 0 or 24 and 2. Because those are the variable components, and if we are incurring variable SG&A per unit, then they're relevant. Okay, so that was what I was looking at. Okay, so the problem is not clear enough to tell you. If we assume no commission, we are making a contribution margin of $6 a unit. If we assume a commission, we're making $4. What are our additional fixed costs? 0. So our change in net operating income is going to be $6 a unit. Let's just assume 6. And if we're going to sell $12,500, that's going to be our new net operating income from the sale. So of course we'll take it. Why would we pass up, whatever it is, 75,000 or whatever? So that's again, and this is where it gets tricky. I made one assumption, the book made another, in terms of what they told you. But these always are relevant. If you don't make the product, you don't need the materials or the labor or the variable overhead. And if we do make additional products, we incur that cost. So even selling it at 30, which is way lower than the 44, we still can make $75,000 from this sale. So of course we'll take it. Or will we? What's not in here now? What are the we're just going to quit after this one. What are the numerical issues that we have to worry about? All right, so we say, oh great, yeah, we'll sell it to you. We'll sell it to you for 30 and we'll make $75,000. Okay. What are some of what can come back and bite you from this?
A lot of people want the same price.
Okay. Suppose your customers hear that, wait a minute, you sold to them for 30 and you're making me pay 44. All right, that's one issue. Okay. What is the second thing you would want in this contract before you made the contract with whatever they are, hospitals or us or whatever you're selling them to, the hospital supply company? Yeah.
Oh, something about like a return policy, like you don't want them returning anything because then you're not able to sell it.
Okay. That would probably be that would be worked into the contract somewhere. I'm looking more specifically about this particular sale to them. What would you want to make sure of before you sold to them?
That they realize it's a one-time special price in addition to the other customers. They might come back again next week.
Yeah. Okay. What else? If they're in your area, what's to stop them to go into your customers and undercutting you? They paid 30. They can go to your customers and say, you're paying them 44. We'll sell it to you for 40. So your customer's going to get very angry because they've been paying 44. They bought it for 30. Okay, the customer's going to take the deal because they're going to save $4. You're going to lose the customer. So that you've got them, and none of this is in the numbers. All you know is you're going to make $75,000 more if you take this order. But you got to worry about all that other stuff that doesn't get in the analysis. That's why I keep saying this is the starting point of your decision. You can't make any decision until you have the number, and then you worry about what's not in this number that I have to worry about. And unless you get this group to agree to all this, you might not make the sale. So we'll come back next week. We'll do scarce resources and joint processing. Joint processing is the least important of them all because it is very industry specific. The other four you see all the time in all sorts of industries. Okay, so for next week, you're now on a schedule of one problem, one case. So problem 30, CVP analysis. in case 231. It is an ethics analysis case, so I don't think there's any feedback on that one. I don't think there are any numbers. There's definitely feedback on 30 on the technical parts. Okay, as some of you found out. Be careful. Not necessarily tonight, but tomorrow. Be careful. Going around.
Where'd you get the 75,000?
So we're going to make $6 a unit. We're going to sell 12,500 units.
Contribution margin.
Okay, because there's no fixed cost. So every unit we sell is giving us $6 toward profit. There's no more fixed cost.
I know, and I'm like,
There's the 50,000 are there whether we have excess capacity or not. Make sense? No.
Where's that 6 coming from?
We're selling it to the company. Let me get rid of it.
Oh, I didn't see that up there. I was stopped at the block.
Yeah, we're selling it to them for
Right.
30,
Right.
and it's costing us 24 to make it, to make an additional unit. So we net out $6 from every unit we sell.
Right. Okay.
Now, if we had to buy a special piece of machinery to take this order, then yeah, we would have additional fixed costs. But in this case, we have excess capacity, it's what we're already making. All we're gonna pay is material, labor, and variable
I was gonna
overhead.
say, how long did you drive now?
Okay?
I didn't see the
No, that's okay.
sale price 30 up top.
At this time of the day, it's a long
A
day.
lot of numbers.
Yeah, it's a lot of numbers. Oh, okay. Oh. Actually, could you grab me the slip? I just realized I need that. I have to download that. Thank you. Just shut it off. And I just, thank you.